Good morning, everybody. I'm Alex Betourne, Scientific Director for the Rare Disease Program and the Critical Path Institute. Thanks for joining us today. This is our program, the RDCA-DAP 7th webinar of this year. So this will be the last one in 2021, but stay tuned for next season in 2022. And as for any good show, it's only gonna get better next year. I'm very pleased today to introduce you to Dr. Ramona Walls. Ramona is Associate Director of Data Science at the Data Collaboration Center of the Critical Path Institute. She leads the Semantics, Ontology, and Metadata team, and I've been working to build our platform with her team. Also with us today, Amanda Borrens, Executive Director, Data Science for the Data Collaboration Center. She will be part of our Q&A at the end of this session, following Ramona's presentation. Just to start with a few cleaning items, this is a recorded webinar, and it will be available on our website for you to see after. During this webinar, you can enter your question in the question and answer chat box on the right side of your screen. Make sure you address your questions to all panelists so that we can capture all of your questions, sort them, and ask these questions to Ramona and Amanda at the end of this webinar. With these minor housekeeping details, we can get started. Ramona, please take it away.
I can't unmute myself.
We can hear you, Ramona.
You can?
Yes.
Oh, okay, good.
Everything is fine.
There's no button to unmute myself. Okay, but I don't need to. Thank you so much, Alex. That's great.
We hear you loud and clear.
Excellent. Okay, thank you so much for that introduction. So I'm going to talk today about making rare disease data count. I don't think I need to explain too much detail to this audience why rare disease data is so precious. For every rare disease, there are only a handful of patients. They tend to be scattered around the world. And so getting data from those individual patients, each patient's data is essentially very precious. Patients spend a lot of time filling out data, collecting data for filling out forms and registries, visiting doctors, and we really want to make sure that the time that those patients spend and that you as registry builders, as care providers, all of the people who are collecting and providing data get the most value possible from that data. So that's why we spend a lot of time on our curation process. The RDCA-DAP, I hope has been introduced before in this webinar series, but for those of you that might be joining for the first time, I'll give a brief introduction. So the RDCA-DAP stands for Rare Disease Cures Accelerator Data and Analytics Platform. The platform here, you see a schematic view of our platform. Essentially, we take in, on the left side, you see that we take in data from a bunch of different sources. It gets stored into an archive. It undergoes some curation that includes annotation with metadata, standardization, mapping to ontologies, and then it becomes available through our platform for analysis, both by external researchers and the CPATH quantitative medicine team. I'm going to talk to you today about the middle part of this figure, that curation process and everything that happens during that piece. What happens basically from when we take raw data in from the providers before it goes to the analyst and who want to be able to develop solutions with that data. But before I talk to you about those different pieces, I would like to give you some background knowledge. So I'm going to be using, oops, looks like I went forward, sorry. I'm going to be using a lot of terms during this talk, like ontologies and knowledge graph and fair data principles. And many of you may be familiar with those terms, but they may be new to others of you. So I want to spend a few minutes just providing some background on the vocabulary that I'm going to be using. The first and foremost is fair data principles. So for those of you that have not heard of fair data principles yet, FAIR stands for findable, accessible, interoperable, and reusable. Why are those important? So if you are sharing your data and you want other people to be able to make use of it, these are the principles that allow them to do so. So what does it mean to be findable? It means that the data has to have rich metadata and it has to have a unique identifier so that you can find it, a resolvable identifier. And that means a URL essentially. The data have to be accessible. That means that they can be downloaded using some standard protocols, or at least they can be accessed. So that means that they should be accessible on the web. Interoperability really has to do with metadata. It has to do with standards. It has to do with making sure that other people who come to use your data that you've created can understand and know what it means. So really good metadata is very important. And reusability, that's very similar to interoperability, but it means that you know, what stops people from reusing data? I think one of the biggest reasons that people give for not reusing other people's data is that they don't trust it. That's just honest, right? What makes it so that they trust your data? If you really describe how you collected it, how you processed it, etc. So again, having really good and clear metadata makes it so people can make that decision whether or not your data is trustworthy and something that they can reuse in their own purposes. The key to the FAIR principles is really all about, if you go and read the paper that describes the FAIR data principles, there are long lists for each of these pieces and what makes them work. But the bottom line is that to really be fair, your data need to have an identifier, they need to have good metadata, and they need to use ontologies and standards. That is, they need to be described in a very clear way. Because the point is that FAIR data is not just for people. So it's one thing for people to go and read your data. FAIR data is really about making it findable, accessible, interoperable, and reusable by machines, by computers. And so that's why all of these standards and ontologies and metadata and machine readable metadata and open source formats are so crucial to making data fair. So again, I said I'm throwing some words out there. So for those of you that aren't familiar with these terms, and those of you that are, please bear with me. But if they're new to you, I just want to at least provide a little bit of a glossary for some of the concepts I'm going to be talking about a lot today. So an ontology is a set of concepts or categories within a domain of knowledge, and also how they relate to one another. Ontologies are generally stored in a specialized code. The most common code that's used for ontologies is called the Web Ontology language, which is abbreviated OWL or OWL. And that OWL is what translates human knowledge into a machine readable form. It also supports logical inferences. So you've got relationships. You can imagine a classic sort of relationship in an ontology would be my hand. And then I would have a concept for a hand. I would have a concept for a finger. And I could say that finger is part of some hand. And I can write that into a language that's very explicit, and I said machine readable, so that when I do a search and I say, find me all of the diseases that affect hands, for example, if someone has stored a piece of knowledge that says this disease affects the fingers, then that my search is going to include that result for finger, because it knows that a finger is part of a hand. That might seem like a really obvious thing to you and I, but to a computer, that has to be explained and be made very explicit, and that's what ontologies are really useful for. There are tools that go along with ontologies called reasoners. Reasoners are what allow you to provide the logical inference. So a reasoner is exactly the tool that would do what I just did, a reasoning in my head, saying that I know if part of a finger, then it's also part of a hand. But the reasoner is the tool that allows a computer to infer those facts, just like we can infer them as people. And finally, I'm going to use the term called knowledge graph. I'm going to talk about the knowledge graph that we're building for CPATH. And a knowledge graph is a network of real-world entities. So unlike an ontology where you've got categories or concepts, knowledge graphs encompass real world. They're really about data, about things in the real world, whether they're objects, events, and the relationships between them. So they're often stored in a graph database, very similar to an ontology. But the difference is that they have data versus concepts. And here's just a pictorial representation of this. I don't think my pointer, I don't know if my pointer is visible, but here on the left side, you can see an example of an ontology. This is taken from the Human Phenotype Ontology. And so I know these visuals might be a little bit small for you, but you don't need to understand the detail. But you can see things like you've got an abnormal eye morphology, which is an abnormality of the eye, which is a phenotypic abnormality. So these are very generalized concepts. And then on the right side, again, this is not something you're expected to read, but this is a picture of a knowledge graph. This one is taken particularly from a COVID-19 knowledge graph. But each of the ovals in here represents actual real world entities. So there are just numbers rather than labels on here. There are numbers that represent, in this case, the green ones are identifiers from PubMed, which is that is their citations of a particular papers. And the orange ovals are the identifiers for genes. So this graph is representing where particular genes are mentioned in different publications and trying to show the relationships between genes mentioned with chloroquine in this particular knowledge graph. So let me then go, with that background knowledge, let me go into a little bit of describing how we go about integrating data within RDCA-DAP. What is it we're trying to achieve? Our goal really is to take data from diverse sources and of varying quality and, make them as useful as possible. So we're getting data in whatever format it was collected in and whatever state it was collected in. It may not be fair, but we're trying to make it as fair and as useful as possible. And so we are guided by those FAIR principles. What are some requirements? When we set out to design this new data integration pipeline, we had some basic requirements. First, we wanted it to be reproducible. That is, we're going to use scripts wherever possible. So we're using R and Python, for example. We're using standard, where we cannot automate things, we use standard operating procedures to make sure that our data managers are following the same sets of practices each time. We're using source version control. In our case, it's GitLab, but there are many different source version control options that are out there. But we want to make sure everything that we do is reproducible. And that's really important, again, for regulatory science. If you want to be able to show what you've done, how you've changed the data, if you want to submit anything for a regulation, you need to be able to prove exactly what you've done with all of that data. We also need this process to be efficient and scalable. So we have a lot of data. Right now, we've already got, I think, 52 or 59 data sets coming into the RDCA-DAP, with more on their way all the time. This is a very labor-intensive process to curate them. So we want to automate that curation process wherever possible. And it's also really important that we ensure privacy. So we have to make sure that the data because this is patient data, we want to make sure that everything's done in a secure cloud environment where there will be no accidental leakages of the data. And finally, we need to make sure that our data are interoperable. So we're leaning heavily on the use of ontologies and different data standards. And here's a fairly complicated picture. I'm going to walk you through it step by step that shows the entire curation process from start to finish. So let's start here in the upper left. We've got our data coming in. So we have a lot of clinical trial data, natural history data, registry data. We will in the future be integrating genomic data, possibly imaging data, other omics data. So the point here is that this ingestion and curation process is neutral to the type of data. It works for any type of data. So the first basic step is ingestion of data. Nothing happens without a data contribution agreement. So this is always signed by our data an agreement between CPATH and the data contributors. It leaves the control, the ownership of the data with the people that collected the data, and it makes it very clear that there's no PHI data in it, and it explicitly describes what the reuse conditions are for any data. It undergoes a secure data transfer process. And then we have an automated system that validates the data and generates a report that gets sent back to the data contributors, with the hope that in the future, any shortcomings in the data that we point out will guide them to do better data collection efforts in the future. If they've already done data collecting, then there's not much that can be done about it. But we feel that for many of our contributors, they're working in an ongoing basis, and so we hope that we can improve their data collection efforts going forward. Finally, once the data has been cleared and and accepted as part of the RDCA-DAP, it moves into a secure archive, which serves as the source of truth. So that original data set is never touched, and we can always go back to it and look at the data as exactly as we received it. From there, it goes into the actual curation process, and we call this something we call responsive curation. I'll get to that in a minute about what's responsive about it. All data sets undergo some basic level of curation. That includes creating a data catalog, and also making sure that all of the different actual data sheets within the data set have data dictionaries. We sort of have two levels there: raw, which is the state that just gets a data catalog, and if there are existing data dictionaries, then we reuse those. And then we aim to really, within a few weeks, to get all of our data into the minimal category. So that means it has that data catalog, all of the actual data sheets within the data set have data dictionaries available, and the data are in a common format. In this case, we're using CSV, or comma separated value. In case you're not sure about what data dictionaries are, what we really mean is that if you've got a spreadsheet with data that's got rows and columns, and essentially each column describes a different variable, the dictionary defines what all of those column header means. So if you have a column that's labeled PTID, you might not know what that means. The dictionary makes it explicit. That is the patient ID, for example, right? So we've got this basic curation process that's done through all of the data sets, and then it gets put into our platform, the RDCA-DAP platform. The platform consists of two pieces. There's the FAIR data services, and FAIR data services are essentially the public-facing user interface for data discovery, where you can do data access requests. It will have a sophisticated cohort builder. We're working on that right now, that will include different data visualization tools. And the idea behind getting that basic curation and getting into the FAIR data services as fast as possible is that it allows everyone to see what data are available as quickly as possible. And that's where the responsive piece comes in. So as our users, as our scientific directors are looking at the data, understanding what's in there, they're going to say, hey, this data looks useful for me. Can you please go and curate that? So before we go into that full curation process, which is fairly time consuming, we allow people to see what data are there, and that helps us to prioritize what needs to go into the full curation process. So that's that really responsive piece that allows us to scale up the operations and provide more data more quickly to the research community. So once someone has decided that a data set is useful to them and it's important, it moves into this full curation process. Full curation, again, also kind of like basic curation, has two different levels. The first level is where we standardize a set of core variables. Those include things like demographics, medications, phenotypes, or whatever data variables have been requested by the people who are expecting to use the data. We can also go to to level 4, where all of the data are all of the variables are standardized. For both of these levels, for both the core variables and the all variables, we're using the OMOP common data model. I'll talk a little bit more about that in the next slide. And we're also going into a common format, which is SQL. So it goes into a relational database that allows the data an entire data set to be used and queried across different parts of the data set. An important part here also is some data cleanup. So we note where there are outliers, where there might be errors. So for example, if we find a value that has clearly been put in, say, in the wrong unit, say it's 100 times greater than every other value, that might make it, we might say, okay, this was probably the wrong unit. We can go back and change the unit, but we always store the original value. We never get rid of those original values when we're cleaning up data. We want to make sure that there's really good provenance and traceability from the data that came into us to the cleaned up data that we're producing. So then that fully curated data goes back into FAIR, where it can then be requested and moved into a workspace. So the workspaces are this other piece of the RDCA-DAP, of the platform, and that workspace is where people can actually do analytics and do analyses on the data. There's one more piece to the curation process, which is step 5. It's not numbered here, but the step 5 is integration into a knowledge graph. So these standardization steps of moving things into the OMOP common data model allow data across different projects to be used together at some level. Because they're in a common data model, you can say, okay, we've got all of our demographic and the data in the same format. We've got all of our all of our medications standardized to RX norm. We've got all of our laboratory measurements standardized to LOINC, so we can look at data from multiple sources and sort of compare across those different sources. But in that relational model, it's still a bit difficult to do to really have fully integrated data across multiple sources. There are always going to be small differences in the data sets in the way that something was collected. So one person might use a particular laboratory test and another group might use a different laboratory test to get at the same value, right? To get at the same, to test for the same, you might measure for blood glucose level. You might do 2 different tests, for example. And using the common data model does allow you to at least see that, but it makes it difficult to do queries and really look across those different data sets that have slight differences in the way that things were measured or recorded, or that are, for example, different but related diseases. And this is where the knowledge graph comes in, is really important. So the knowledge graph, by taking all of this standardized data that's already in the OMOP CDM and converting it into an ontological form by using ontologies to map it and turn it into a graph, we can really start to establish connections across different types of data. So we can have a graph that shows that there's an upper category for all neurological diseases, and then there might be neurological diseases in childhood and adult neurological diseases that affect breathing, etc. So you can start to have these hierarchies, these multi-hierarchies that let you search across different aspects of diseases, different facets, as it were. And really start to look for connections that might not be that visible in a standard tabular or even relational data set. The other advantage of using the knowledge graph is that we're using a common model called BioLink that was developed as part of the NIH NCAT's data translator project. Other projects are also using that BioLink model, and even if they're not, if they're using some standardized formats, this allows us to try to federate and bring in some external data sources as well, or at least link out to them, like I said, through a federation project. So we're working, for example, with the European Joint Program on Rare Diseases, or EJPRD. We're currently doing a pilot project where both of us are mapping our core data, some core data elements, to this BioLink model, so that we should be, and to demonstrate that we should be able to query across those different data sources, even though they're stored in 2 different places. So that's a pretty complicated data integration process. For those of you that are technical, I hope it made sense. For those of you that are non-technical, it might seem a little overwhelming. So let me just kind of summarize it into some key points here, and try to just take up some of the summarize some of the benefits of this. With this responsive curation process, we can make our data available as soon as possible while improving the data quality in a stepwise fashion. So we don't have to just sort of put the data into a black box and wait 3 months for it to come out in a fully curated. We can start to work with it while we're undergoing that curation process. All data receive some basic level of curation, so that makes them discoverable as quickly as possible. That means our scientific directors, external researchers, and patients can all request access to that minimally curated data, or request that we curate data sets or individual tables as quickly as possible. And finally, when we get to the full standardization interoperability, that makes data really, first of all, we've prioritized the data sets that are most in demand. But we're also, as we're gradually working towards standardization and interoperability for all data sets, we're creating a knowledge graph that allows for discovery and to make connections that would not otherwise be visible in these very disparate data sets. I'll just reiterate a little bit some of the some of the steps that we take to make sure that we are protecting patient privacy during this process. CPAP has for many years followed safe harbor privacy principles, and we're continuing to follow those. PHI data are removed before the ingestion, as part of our data contribution agreements. We ask contributors to say that to remove all PHI beforehand, and then a curator checks that. We are essentially receiving what's called limited data, which means that even though personal identifiers, etc., have been removed, dates are left in the data set, because those dates are what make it many of the different analyses possible. For example, understanding the progression of a disease. However, dates can also cause problems in privacy, so we undergo a fairly complex pseudonymization process before we share any data, where we apply random shifts to the dates. We make sure that no patients ages over 89 are revealed, etc. So by the time the data gets to our end users, it is fully anonymous. We have internally, we call it pseudonymized because internally we could reverse those dates, but we never make those dates public. So they are fully anonymous before they the data become public. Also, as I mentioned, data requesters have to sign it. Maybe I didn't mention this. Within the FAIR data platform, when you request access to data, you have to sign a data use agreement. And that DUA ensures that you'll protect the data, at least to the level specified in the original data contribution agreement. So that's another step of privacy protection that we undergo. Our platform is fully secure. The data are encrypted during transfer and at rest. And the platform, both the FAIR data services and the workspaces, have full audit logs, so that we can see, so that an administrator can see exactly what's happening to the data every step of the way to make sure that there have been no data breaches. So let me talk a little bit more about standardization and some of the standards and ontologies that we're using. I mentioned before the OMOP Common Data Model. Observational medical outcomes. I don't even remember what OMOP stands for exactly right now, but this is OMOP has been developed by the Observational Health Data Sciences and Informatics community, or ODYSSEY. And so OMOP is a relational model. It includes existing standardized vocabularies like MESH, SNOMED, LOINC, RxNorm, and so those are, you could think of them as sort of simple ontologies in that they do have some hierarchical structure and some logical relationships within them. We have CPATH as part of we've joined the ODYSSEY community, and we're part of both the registry and clinical trials working groups. OMOP really grew out of the EHR world and was developed originally for medical, for medical, I guess, many different types of treatment centers, right? But primarily EHR data. But it's also being used now to describe registries and to describe clinical trials. But there's some tweaking required to the OMOP CDM model to make it work with those data types. So we're actively involved in helping to understand and make those, to make sure that those adjustments to the OMOP CDM are sensible. We continue to work with the CDISC standards organization. We will support the SDTM, or study data tabulation model, wherever data need to be submitted for regulatory purposes. Much of our existing data is already in SDTM, and so we're continuing to make it available in that format where required. So we're kind of living in between that OMOP and SDTM world. In addition to the vocabularies available in OMOP, like MESH or LOINC, etc., we are using a more semantically rich set of ontologies to try to, for building our knowledge graph. And for that, we are largely following the standard, the Global Alliance for Genomes for Health, the GA4GH phenopacket standard, lists a number of different ontologies that they recommend, and we are using that same set of ontologies. The reality is that for some of the data types that we're working with in rare diseases, particularly for natural history studies and registry data, which include a lot of questionnaires, there is not full coverage of ontologies. That's just something we knew going into this project. So what we're doing is working with the rare disease community and with the ontologies communities to try to expand existing ontologies wherever there are gaps. So we will be contributing to these ontologies. We're trying to avoid making new ontologies wherever possible, because the best practice is, if you're really going for interoperability, don't create another, don't reinvent the wheel, right? Contribute to the existing wheels and try to make them better. So that's what we're really doing within CPATH. So just to give you a listing, I believe that this recording will be available afterwards, so you can go back and look at this more slowly. You can also go to this this link on the PhenoPackets, on the GA4H PhenoPacket schema to get this list. But many people often ask me, what ontology should I be using? How do I know? There's so many ontologies out there. If I go to a source like BioPortal, which lists literally thousands of ontologies, how do I know which ones are appropriate for my disease area? So that's why we're taking this community recommendation from the PhenoPacket standard to describe diseases. We'll be using the Monarch Disease Ontology, and the advantage of that is that it already integrates multiple disease ontologies, such as the Human Disease Ontology, the Orphanet Ontology, and others. For phenotypic features, symptoms, etc., we're focusing on the Human Phenotype Ontology. Describing anatomy, there's the Uberon or Uber Anatomy Ontology that represents both anatomy and development. There's a units of measurement ontology. Oh, sorry about that. There are, okay, there we go. Genotypes, LOINC is being reused for assays. Drug Central, again, we could have a whole discussion about drug descriptions and which ontologies and vocabularies can be used there. And I would say that our team's view on that is probably still evolving. So I'm not going to give you a hard and fast recommendation about which drug vocabulary to use. NCIT, the National Cancer Institute Thesaurus, is a really important resource for all of the coverage that it provides for things like procedures, findings, etc. So this is not a full list of the ontologies that we'll be using, but if you're looking for a place to start, I think this is a good place. Okay, so let's catch a breath for a second. Take a drink of water. That was a lot of technical information about what we're doing here at CPATH to try to make the best use of the data, to get the most value from the data that we're receiving. But what we would really love to see is better data coming into us from the rare disease community. We would very much like to be part of an effort, of a broader community effort to improve data quality standards, and to help make rare disease data more fair. We plan in the future, this workshop is just a first, the 7th webinar is really just a first step. We're really planning to develop some more training materials and workshops going forward that we can give back to that rare disease community to help you supply us with better, higher quality data. So what are some of the steps that you can do? Well, before I go into those, I'm going to just point out some of the most common problems. We at CPATH have been curating data for 15 years now. So we've seen a lot of data, and we've seen a lot of the really common problems. And these are some of the problems that we see most frequently. So there are missing data and missing fields. Now, sometimes that can't be helped, but sometimes it can. There are no or incomplete data dictionaries. Data dictionaries are extremely important for the reusability of your data. There's often a lack of longitudinality in data. So that, again, that has to do with that. In legacy data, that can't be changed. You can't go back and tell somebody, don't collect data this way, go out and make sure that you follow up and collect over the years. But going forward, hopefully with registries, we can say, it's really much more useful if you can track your patients over some years. That's going to give us a lot more valuable data. There are some key data management issues that tend to be pretty common. The lack of globally unique and persistent identifiers. For patients, I think that's something that the community is pretty well aware of. There are a number of solutions being developed, and we hope that some of those will start to be adopted. Data edits are not traceable. People go in and see problems with data and then don't note the change. That's that's a really kind of that's a big no-no for regulatory submission, right? So it's really important that any changes that you make to your data, that you record the original value and the new value if you make any changes. Difficulty in determining duplicates or patients across studies. Well, that goes back to the globally unique and persistent identifiers. If identifiers are used, this would essentially solve this problem. And again, that's a whole nother topic of discussion that we won't go into too much, but we can discuss more during the Q&A if wanted. And data just aren't fair. A lot of organizations, particularly smaller organizations, volunteer run, may not have the funding to hire data managers, may not be aware of all the fair data principles, and so they just aren't being applied for whatever reasons. Often there are no standards used, no common data model. Data come in all different data types and formats. One of the classic problems is getting a spreadsheet, an Excel workbook that has 4 data tables on the same sheet, right? And then someone has to go in manually and separate those and turn those in. So always better to put things into machine readable common formats that can be easily parsed where possible. And of course, there are challenges that have to do with ethics and regulatory issues, because we're working with patient data from all over the world, and there are different laws and different regulations and different ethical norms in different places. So how do we start to address those? Can we, as a global rare disease community, start to try to find some common ground in terms of regulations and ethical norms across different jurisdictions? And of course, we have to be very sensitive to past or even contemporary misuse of data. Do our best to avoid that, and not just avoid it, but really compensate for it, to ensure that we are using data in a just and equitable manner. Okay, so what can you do then to try to avoid those problems? Well, first, I think just being aware of those problems will help you to try to avoid them going forward. But if you're building a registry, if you're collecting patient data in whatever form, make sure that you're aware of the fair data principles. Make your data standard, use standard machine readable formats, use common data elements where possible. NIH publishes some great catalogs of common data elements that can be reused. Reuse ontologies wherever possible. Advocate for the use of globally unique identifiers or permanent identifiers for patients and for specimens, for other elements that can be reproduced, that can then be traced, while protecting privacy. That's the challenge. Remember that when you're collecting data, that your data are going to be, if they're going to be reused, they're going to almost certainly be anonymized going forward. So how can you capture data that will retain the most value after anonymization? So this is particularly important if you work in a rare disease that affects older patients, because there is a regulation that says that you may not disclose any ages or dates associated with anyone over the age of 89. So what can you capture to help to maximize the value of that data? And invest in data management. So if you're running a small patient registry, first of all, bless you, you're doing great work. Can you find a way to afford some advice on data management, right? This is an investment that will pay back 100-fold, because it will mean that the data that you worked so hard to collect will actually be usable in the future. There's nothing more sad to us than seeing patient data that's been so arduously collected that we can't use because it doesn't have units, or there are no dates on tests, or it's unclear which tests go to which patients, etc. Right? So if you're going to do it, please spend some money or some time on data management to make sure that your data are valuable. And organizations like NORD are an incredible resource there who can help you with data management issues. Oh, this is just a quick little aside about when I talked about common data elements. The European Joint Program on Rare Diseases has published a list of data elements for rare disease date registration. So any rare disease data set that's going to be registered through EJPRD is asked to, I don't know if it's required or at least suggested to collect at least these data elements for all data sets, for all patients. So your identifier, date of birth, sex, etc. So there you can see this list. This, if we could get consent to reuse of data, right? So without this consent, then the data, particularly if they're coming from Europe, the data are not useful at all, right? So it's really important that everyone who's collecting rare disease data, again, this data is so precious, make sure that it can be reused. Get at least this very basic information from your data sets. And with that, I'm just going to wrap up with a few conclusions. I talked about the CPATH data integration process. Our goal there really is to increase the power of rare disease data, not only by cleaning it up and making it more fair, but also by merging across multiple data sources to literally increase statistical power, right? By trying to create larger data sets where we can merge across different sources. For registries, remember, the best time to ensure high quality data is when you collect it. That's not just for registries, that's for everybody. So get a good data management plan in place before you collect any data and make sure that you are following FAIR principles as you're collecting the data. Standards, a lot of people don't like standards. They complain, they get in my way. They say, oh, they inhibit me from doing this or from doing that. But they really do add a lot of value to data, especially for regulatory impact and integration with other sources. So make standards your friends, learn to love them and learn to use them. And with that, I think I'm going to thank you all for listening. And I want to point out here that you can read more about the RDCA-DAP via CPATH at this first link. The DAP is now open, and you can now go there. It's a very simple process to request access. And you can fill out data access requests for reusing the data. And this is the access portal.rdca-DAP, portal.rdca.cpath.org. And if you have data that you would like to contribute to the RDCA-DAP, please reach out at this email, rdca-dap@cpath.org. Reach out to Alex. He's the one who's going to help you on that front. And now we go to the Q&A, I think.
Thank you, Ramona. That was just terrific. I think I'm gonna have to go back and listen to that over and over again. Before we jump on specific question, I just wanted to reintroduce again Amanda that is joining us today, and maybe Amanda, start with like a global comment, like how great is this? How unique is this? How helpful do you think this work is to our program, but also patients and the scientific community? I think it would be great to hear your thoughts.
I think this work is really exceptional in that the application of ontologies and semantic tools and all of Ramona's background and expertise that have helped us guide our team are really unusual for, especially for patient-collected registries, right? Adding that level of technical investment to be able to maximize the usage of all the data that come in from these different sources. I think it's transformational, honestly. It's something that's really cutting edge. It's something that is starting to be visible within industry, that pharma are spending hundreds of millions of dollars on using semantic tools to go back and mine their own data over the years for additional insights. I think the fact that rare diseases present such a challenge in that we want to find information for any patient with any rare disease, and that's really challenging when there's a disease with only a handful of patients in the world. So this really, honestly, Alex, is the only way that we can extend those different inferences past 50 patients and into patients who have other semantic concepts in common, right? And Ramona, maybe this is the right time for you to give that great example from the Monarch Initiative of a patient that really her life was changed.
sorry, I should have had some backup slide for that. You know, but what's really going on now is the ability to use these knowledge graphs to look for data across many different resources. So the Monarch Initiative is a project that's really looking to integrate rare disease genetic and genomic information to look for associations between genotypes and phenotypes, not only in humans, but across all organisms. So in the genomic community, what we've realized is that because, of course, genotype to phenotype relationships are conserved across species, we can look at relationships between phenotypes in model organisms and understand that what genes are controlling those, and thereby start to understand what genes control different phenotypes within humans as well. So Monarch has built this great knowledge graph of genotype to phenotype associations. There was a rare disease patient who was born with a particular phenotype. They did not know, she was like many rare disease patients as an infant, she was undiagnosed. No one really knew what was causing the problem, what was the link to it. They were able to sequence both of her parents as well as the patient and identify mutations in a particular genes that were shared among the three of them, and identify, and then using that genotype to phenotype association data built up through Monarch, identify which genes were leading to those particular phenotypes, identify the gene that was causing the disease, and get her treatment, and basically, you know, give her a life so that she is able to go on and survive. And this is actually, it's really interesting. At meetings lately, I've been seeing more and more presentations where this is becoming the norm in hospitals, where patients, as soon as they go into an ICU with an unidentified disease, they do a genomic screening of the parents and the infant, and can now like reduce the time to diagnosis of rare disease from years to a matter of days sometimes.
Thank you, Ramona. Looks like Amanda is having a little issue, but I think we have a few specific questions from the audience, and we can jump on that. I'm getting a few questions on the audit part. Is there a standard that you use to document edits that have been made to the data? Is there an audit log in the database for each data set? And how do you communicate with the FDA these changes and edits that have been made to the data?
I think that's probably a two-part answer. Ramona, why don't you take the kind of give the example of how we're tracking changes to data sets in the data science team?
Sure. So one of the advantages of the OMOP common data model is that it has essentially built-in functionality for tracking exactly that change. So when you map data to OMOP, there are for every variable, there's a column for the original value and for the new value, and then we can also, where appropriate, add columns for why the change was made or how the change was made wherever was needed. So essentially, we always store that original value, we store the new value, and where important, we store information about how the new value was derived, for example. In terms of communicating that to, could you remind me, there was like 4 parts to that question.
Yeah, there was. Do you have a standard for the documentation? Mm-hmm. Is the audit log residing in a database for each data set? Mm-hmm. And how do you communicate with the FDA? How are these audits communicated when we intend to do a submission in the future?
I want to jump in with that one just from my experience submitting data to the FDA for device clearance. And it's very similar to what Ramona just described as our process internally, but in clinical trials for devices or drugs, you must submit the full original data. So for example, if a patient name is misspelled, there's a typo in a patient name, you have to submit the version of the data that has the typo in it, alongside a new version of the data where you have a list of exceptions. And that list of exceptions is basically this was changed. It was changed on this date. It was changed by this user with very limited access. And it was changed because we confirmed that spelling of that patient's name was incorrect, right? And obviously that sounds like a trivial example, but that could mean re-identifying a different patient, or, you know what I mean? It could actually affect the ethical submission of data. So In many cases, you have to have every version of the data with every exception noted, and an exception would be any change to the data. And so if there's any sort of quantitative value that's been changed because someone typed, instead of 10, they typed 100, accidentally hit that 0 twice, typically the FDA will require you to submit any statistical analysis that includes that value. They'll require you to include it with the mistake and then separately again with the changed value so that they can look at how much of an impact that change made. So we really it isn't necessary for us, especially patient registries are probably not necessarily thinking of that level of rigor. But I think there are several ways. One is to just keep a version controlled data set so that even one record changes, it becomes a new version. That's something that's simple. Or to keep a list of every field and row and column in your tables that have been changed and on a date and why in a separate place is another thing that you can do. I honestly prefer the version controlled, a whole new copy of the data set with the changes made and have it date stamped for when that version existed. One of the challenges that we have is that we get, for example, new loads of a data set from an ongoing study, for example, or maybe a natural history study. And we're challenged because this year's data might sometimes include all of the data. So you might have a 3-year project and you have year one's data set, and then you have the second year's submission and it includes year 1 and year 2. So what do you do when those data from year 1 have changed between during year 2, right? And so it's really challenging because ethically it's questionable what you do, which version of the data do you go with, right, when they don't match. So we have lots of conversations with people about that. So I'd say just making sure that if you're collecting data that you're very clear about every single change, the date and the reason for every single change to the data is important.
And I have it's almost a joint question to that, I think, about the GDPR. So the platform is located in the Netherlands and is GDPR compliant. How does the ontology system and the curation process that you implemented plays with the GDPR stringency on data processing and edits that we might be doing to get them into the platform format?
So, the data tracking, the provenance tracing, edit changes, logging, everything, that's actually fairly straightforward with relational databases because people have been doing that for a long time. We're really doing something very new in building a knowledge graph that is regulatory compliant. Knowledge graphs have traditionally been like they've been a little bit loose in the sense that, we build a knowledge gap because we're trying to bring in so much data that we can allow for a fair amount of noise and error in there in order to answer some questions. Having to include traceability changes within our knowledge into a knowledge graph, as well as the other big challenge of having to include differences in access permissions across data in a knowledge graph is something that's I think really novel and that we're doing that I don't think has been done before. We are essentially building a really sophisticated knowledge graph that includes, for every node that's a data point, it also has to have connections to nodes that say who has permission to access this data, what was the previous version of this data. All of that traceability has to be built into a graph, or at least can be gotten back to from the graph. So this is a real technical challenge that we're facing, and I think it's actually pretty exciting to see. If you come back to a talk, I think next fall we can actually provide you some examples and demonstrations of how we will do that. But just rest assured that that's something that we're super mindful of preserving throughout the entire curation process.
I think one note I would add to that about GDPR is that 2 things. One, that we have cloud-based services. So our platform, the servers that support our platform are physically in Amsterdam. And so that helps us to comply with GDPR in cases where the data can't be moved between jurisdictions. That's one special note. And then the second special note about GDPR is that the data that we receive are de-identified, and we don't get any sort of key to re-identify patients. So that does exempt us from some of the aspects of GDPR where you might need to remove someone from a list because they're in your database. If you can't identify a patient from our data, then it's essentially not possible to remove a particular patient because I couldn't possibly know which patient that was in our database. So 2 special notes, but there's a particular question in the chat, Alex, if you don't mind me sort of stealing your job. I've been itching to answer
go
this.
ahead. I was just going to jump on the OMOP question. Is that the one?
Okay, well, let's do that first because I want to talk about patient registry and that definition.
Okay,
So,
just
sort of
so
smart.
yes, there was a question on the Observational Medical Outcomes Partnership, or OMOP. Thank you, Google.
Thank you.
Thank you, my colleague Sydney. I'm not exactly sure I completely understand, but basically, how does OMOP hold up with capturing real-world data? And I think before that question, Brett is telling us that OMOP does not support clinical trial data. So maybe if you could jump on that, and then we'll end up with a registry question, Amanda.
So in terms of supporting real world data, OMOP grew out of that world, and it very much the model is designed to capture real world data. So it has tables for it has a patient table, an observation table, an event table, etc. So it does actually capture real world data very well, in my opinion. In terms of clinical trial data, no, it was not designed to capture clinical trial data. The clinical trial working group within OMOP is working very hard to try to build some reusable mappings between SDTM and OMOP. I think the goal is to go from SDTM to OMOP first, going from and then tackling the challenge of going from OMOP to SDTM. But I will say that CPATH particularly has a ton of experience going from whatever format into SDTM. So we know how to do that, and we are definitely trying to share that knowledge with the Odyssey community. We have just about finished with our partners our first mapping of a very large integrated clinical trial data set to the OMOP model, and that will be available on the FAIR platform fairly soon.
Thank you. Amanda, last question.
Well, it's 2 questions, but they overlap a little bit, Alex. It's about defining a patient registry and then recommendations for data management for a small patient registry. So I would say just to this audience, patient registry, or even the term registry, is actually a broad spectrum of definitions depending on the person that you ask. So I would just very loosely say that my personal definition of the difference between a patient registry and a natural history study is that a natural history study is typically collected by a research organization, say at a medical school that's residing within a hospital, a teaching hospital, obviously. So typically that would kind of define the difference for me, is that you've got people who are accustomed to collecting patient data in a really scientifically rigorous way and asking questions in a particular and specific way that will get a consistency of answers from patients that are comparable. Whereas a patient registry, I would loosely define as any set of data that's collected by patients, patient groups, or families, right? So it might be administrated by a group like NORD, but the people who are actually submitting the data and kind of owning the data are the patients or caregivers themselves. And so the last thing is, I'll just put a plug in and say, if you submit patient registry data to the RDCA-DAP, we are working on a system of giving receipts with some feedback. We have lots of information that are going onto our website about how to collect patient registry data in a more rigorous way. And then we're also aiming to publish a paper within the next quarter or so that gives some really specific lessons learned about bringing in patient registry data and sort of some of the data challenges that Ramona mentioned to us today, but also with some solutions, guidance, suggestion, references, appendices, websites, things like that. So we're really, I think, invested at CPATH in trying to help people collect data in such a way that it will really maximize its usefulness.
Well, with that, thank you, Amanda and Ramona. That was a really great webinar. As I said in the beginning, this was the last for RDCA-DAP this year, but this webinar series is ongoing. We are going to have our next webinar, I think, in January. So stay tuned for more information on this. And also, as usual, don't hesitate to reach out to myself or to the general email if you have any follow-up questions. Thanks everyone for attending this webinar today.
Great information, Ramona. Thanks, Alex and Ramona.
Thanks, everyone.
Thank you.